we are going to create an object-oriented program that calculates the diameter, area, and circumference of a circle. With the basics of what we're doing with this program, you could do any mathematical calculation. We are going to, I've already created my folder. I'm going to create my class file. My class file is going to be circle. Quite often you name the class file as a generic sort of name for whatever you're working with. So we're working with circles. So that makes sense. How do we define a class in Python? Yeah, isn't that nice? So it's going to be a circle calculator class. All we're going to do in here is calculate stuff.
So I have a quick question.
Sure.
Yeah, why do we have to always make the first one capital?
It's a convention, meaning everybody agrees to do. All right, so we have a Circes circle calculator. We're doing uppercase on each of these, which is called camel case. And do I say anything about what I'm doing? There's the, oh, Rod, look at that. I gave you everything here, didn't I? Ah, well, that's way too easy. I have to make it more difficult. All right. So we're going to not have an init function, it looks like. We're going to do setters and getters with this. So we define a circle calculator class. It has nothing in it. We do need to have some setter functions and getter functions. And since we're working with pi, almost all programming languages except C++, well, I don't. We want to import math. Whoops, I'm in the wrong place, aren't I? We import up here. We need to import the math library to get the built-in pi constant. So we can use it when we're multiplying by pi. We have two different types of methods that we commonly use to get information into a class, get information out of a class. So if you think of a class as being a container, which it is, it's a container. Where's my, there it is. There is our class. Everything stays inside the class. It's a container for code. I can reuse this anywhere. If I want to get something from the inside, a value from the inside out here, I use a getter function into my main program, which will make square. Well, relatively square. So if I have variables in here and I want to get their values over here, I use a get function. I want to get this information out of here. The information still stays here. I'm getting a copy of that information. If I want to change information in here, I use a setter so that I can set new values for whatever variables or attributes are in here. Two important concepts about OOP. And what's your acronym for it, Mr. Sean? For OOP?
Poop.
Poop. Python object-oriented programming. I think that's hysterical. Wasn't that a video? I think I watched that. I mean, that part's hysterical. It was a really good video. Ooh, I should put that in the, I don't need to record all these oohs. All right, taken care of. So we are going to, first thing when you're calculating the information about a circle, we need the radius. So that means information coming from the outside into our class. So we have to define our method, which the common wording is set, and then you use whatever variable thing you're going to set. So this isn't a variable, this is a method. And we have to have self. Self holds everything in that big circle, holds everything together. But we're bringing something in from the outside. So we have to put in a parameter here saying radius, so that when we call this method from the main program, we're passing this value into this location. Self does nothing other than glue everything together. That's all self does. Now, when we get that value passed in, we want to do something with that value. We're going to assign it to the internal value, which we can use anywhere at all in our class. Oh, I got the wrong connotation there. There. So this is coming from the outside. This is the same value. We're assigning it to an internal variable inside our class. Then we can do self.radius anywhere, which we'll do. We'll use self.radius to make some calculations. All right. So the next one says, and I'm going to put in this to do, because I kind of pseudocode the whole thing. We need a method to calculate the diameter of a circle. And the formula is diameter equals 2r, where r equals radius. Oh, I should do the one with pi, shouldn't I? Yeah, let's do the one with pi. That's the area of a circle. Let's do the one with pi. Because that's something we haven't done before. Is use a constant like pi. There. So our area is pi r squared, which that should sound familiar to you from like high school geometry or something. So all we're going to do with this method is calculate the area of a square. That's it. We're not going to do anything else with it. So we have to define it. And I don't know, it's a good method name. Calculate area of, that's a little long, isn't it? But it'll work. We're not bringing anything out. We're not putting anything in. This is an internal method that we're going to use inside the class to calculate this. Because we don't need to pass in the radius because we already have the radius right there. No problemo. Well, the formula says area equals stuff. So we need a variable to store area. There it is. We'll store it in there. We put it into a class variable, so then when we need to return this, which we're going to use a separate method to do that, we don't have to pass things around. We've already got it as part of our class. So how do we calculate this? Well, the first thing we need is pi. We access the math library dot pi. That's the built-in constant for pi, which is 3.14 blah, blah, blah. I think we only have 16 characters of resolution because I think we're using 32-bit floating point. So then we have pi. Well, it says just pi r radius squared. So what are the calculations going on in there? How do I translate that formula into computer speak? Mr. Calculus. Anybody? Christy?
So you're just printing it out?
That's a formula. We have to make a calculation. Right now, A is the same as self.area. Pi in programming is math.pi. We reverse it because this is how you do it in math. In computer science, we do it the other way around. Also far, I put in this part. How do we put in radius? Well, how do we pi r squared? What does that mean? Are we adding them together, subtracting them, dividing them, exponenting them? What are we doing? Yeah, see, I left out the one that's the right one. So we multiply it. There it is. Multiply it by, what's r? That's our variable for r.
So,
yeah, see, we didn't have to pass it in because it belongs to the class. We can access this thing from anywhere in the class. Oh, so it's pi r squared. And if we use the order of precedence, we don't have to use oh yeah, it's not gonna work if we don't use the order of precedence, is it? Because it's gonna square first and then multiply by pi. Sometimes the order of operations makes a difference. So if we have pi times r squared, so how do we do self dot radius squared? Does anyone remember the little, well, I can't remember it now.
Isn't it 2 stars?
2 stars? Yeah, 2 stars. There, we have no order of precedence because we're going to take math dot pi, self dot radius is going to have b squared. Because that happens first. Radius gets squared first, then it gets used in the math and the multiplying operation. Now we know what the area is. Whoa, we're doing pretty good. Now, we have brought in the radius. We've made our calculation. Oh, area of a square. I think I'll just call this calculate area. Nobody stopped me on that one because Hope wasn't here. To say, oh, this is not right. Well, Sean's also done the same thing. Well, I think everybody has. So the next one, we have a setter to bring it in. We need a getter, and it's not uncommon to put your setters and getters next to each other. So we end up with a set radius, a get area. You are supposed to do get radius and all that stuff, but I'm keeping it simple. So get means we are retrieving that value from our class. Notice I keep stressing value. That's because of an earlier conversation I had with somebody about object-oriented programming. Because that's what the variable does. It stores a value. And the value is what gets passed, not the variable. All right, so how do we return this? How do we return the area? Oh, what's it doing here? Oh, it's because I haven't finished this up. So how do I return my area? Yes. Did I not stress that enough? So that will return the value. So I can access this from anywhere. I have to access this first. If I try to get the area before I calculate the area, I'm going to have an exception. Because you can't calculate, you can't return something that doesn't exist. And until I calculate something and assign a value to that variable, I can't return it. So we determine the order that we do things in our main program. All right. So let's create our main program. This is enough. We can test this. This is a good way to develop code. Do it one piece at a time, test it. A bad way to develop code is type everything in, hoping that it works, and then you troubleshoot by shotgun and just read the exceptions and see if you can figure out. Nope, nope, nope. Keep it simple. Break it apart. We'll call this circle main, maybe, because I keep talking about main. This is the main program. All right, so we're going to define main. If you don't define main, Python creates one for you. Well, am I doing that wrong? No, I can't remember. IntelliSense probably should help me with that, shouldn't it?
If name. Name equal to name with quotes. Not
Oh, that's pretty good. I couldn't even remember it.
like the
Any quotations?
quotations, not that.
Yeah,
No.
No,
around the whole thing,
take away the
Oh, from here to here
no,
just the
Just
name,
the name.
just the main part.
with the double?
Yeah.
Oh, yeah.
just the name.
Just the word main?
Yes, not name.
Oh, brother.
You need the underscores, Michael.
Like that?
No, on the inside.
I'm not getting different directions. I'm misunderstanding what I'm getting on all of the directions. Yeah, that looks right, but
And then you have an extra quotation at the beginning.
That shouldn't have been so hard. Well, now it's not working. Oh, because there's nothing in here.
Yeah.
If you define something without anything in there, it doesn't like you. If you just want to like put things in until you get the code in, pass. Allows you to have a function or a method signature without having to define what's inside it, if you don't like squiggly lines. All right, thank you for walking me through that. I was not testing you. I was like totally had a mind spasm. Now, a question that how do we create an object from our circle class? Remember, a circle class can't do anything. It's a blueprint, like an architect draws a blueprint before they build a house. So a class is like a plan. Until the plan gets executed, there nothing exists. So how do we create a circle object from our class? Very simple. I'll just call this circle one. Oh, I forgot to do something, didn't I? To use a file and another file in Python, you have to import it there, because my circle is not showing up. What did I call it? Circle calculator? Oh, it's still not showing up.
Circle.
Oh, if I spelled it right, it would, wouldn't I? No, still not showing up.
Lowercase. Circle.
No, that is actually what it is. This is our class. Oh, I have to put
You gotta-
circle in front of it.
You gotta import from circle.
Yeah,
Well, there's 85 different ways to import.
Oh,
Yeah,
from
this is a better
circle
way from
first.
circle. Yes, I don't know. Let's
that's
just,
what I like better.
yeah, let's just quit. Go home. I don't know. My brain has got too many things in its little spasmy place there. Yes, well, I'm not faking this to make you do things. This is like, I don't know what's going on. Anyway, I'll just say I'm having a short stroke.
Smell burnt toast.
Huh?
No,
Now what?
you smelling burnt toast.
I don't know what that means. Is that how you can tell if you have a stroke?
And a lot of people say that you smell burnt toast.
I don't know. Anyway, we have created our object and we imported it. How do we use our methods? How do we use our method from the class?
Circle dot whatever method we listed.
And our first one is circle one dot that we need to do. Which one? We have calculate. See how it has a little different thing there and it has our names. This means that it's a attribute that's inside it. What should we do first? Set
We
radius.
should set radius. Yeah.
So this is like a library of code. But we can't use it until we create an object that we can actually use to use that code. So once we've done that, we can call any of these methods, however many we put in there, we call the method. The dot operator just means here's our object, dot, and that's how we get to the various methods. Set radius. So we can set the radius in a couple different ways. We can hard code it, right? Just to do a quick test. But getting input in Python's not that hard, is it? So can we call our variable in here radius, even though we've used it in other places?
Yep.
No problem, because they're in different scopes. That's the computer sciencey term, a scope, meaning where is something alive? Where does that exist? Anytime we're inside of main, this does not exist anywhere else because we're indented. Python keeps track of what belongs to other things, because this belongs to here. Well, this belongs to here. Two separate places. Two separate houses. We can only access this throughout the class because this and this, glue it together. It's the best analogy I've come up with, and I've said it 100 times. Then you can use it everywhere. Otherwise, if we would do this, the only where place that variable exists is inside. And our inside is from left to right. So whenever we indent, we're putting something inside that little tiny container. It's like we have a bunch of Tupperware containers. Which for guys probably is not a good analogy. Lots of bends for your screws and bolts and things, I guess, maybe, I don't know. So we need to do an input statement, which we've done a million times before. If I can remember how to do it. Yeah, there we go. Now we'll just say, enter the radius. There. Now we have a float coming into here. We have this variable with this value. We want to pass that value over to our class or object. How do we do that? This line is called a signature. So this defines how we use this method. When we're using this as a method from an object, we pay no attention to self. Self only has meaning inside the class or the object, whatever you want to call it for now. It doesn't mean anything outside the object. This does. This is a, what even told me there? This is a parameter which we're passing in. So we don't have to pass anything in for self because outside over here, self does not exist. This is self. This has self in it. Part of an object has all that stuff inside it, which also makes the code portable. I could write many, many different client applications using this. I could write a T-key enter application. I could use this in a website. I could use this on a phone. I can reuse this anywhere. It's one of the nice things about classes. One of the things that's not so nice, object, is that POOP is a good acronym because it's an interesting concept to understand, meaning it can take some time. All right. Now, how do we get our information out of our circle? Because now we've set it. Oh, we have to do one more thing before we can get our area out, don't we? What else do we have to do? We have to calculate the area. Oh my goodness. That's a tough crowd. Yes, calculate the area. Nothing returns here. You don't see anything happening. All we're doing is saying to the object, calculate the area. That's it. So one of the rules in programming is called not single purpose, something like that. Only do one thing. Your methods, your objects, whatever you have, functions should do one thing and do one thing really well. This does everything having to do with our name, circle calculator. And that's all it does. It doesn't display, it doesn't get inputs, it doesn't do squares. It only does circles. And calculate area will not return anything because we don't have a return statement. We're not passing anything in. So this is an internal method that calculates something that we will return, we can get here. Could I have returned self.area right here? Sure. But I'm trying to stress the single responsibility principle. I mean, normally I would probably do that. I just return self.area, not a big deal. Or I just do get area and make it a calculated attribute. No problem. Either way is fine. I'm doing this just to try to separate things out a little more when you're learning stuff. So we calculate it, then what do we do? There's not very many things left.
Return.
Get.
Yeah.
That's the only one left.
Yeah.
We've used them all up. So we can do a couple of things. Once we get a value, we could assign this to a variable here. When you do that, it makes it easier to do a print statement. So I'm just gonna do that. So we have area, you could print this directly. When you're returning something, this whole thing has the value of whatever the variable is. I'm sorry, whatever the area is. The area, this becomes that value because it's returning a value. In my case, I'm going to assign that to area just to make it easier for printing. So we're going to print. We're supposed to use a toString to do this. Probably put that together real quick. So we do def. Have we used this one before? Okay,
I have it.
okay, I have it in this, don't I?
String.
Oh, I don't have the str, I had RPR, which is the same thing, but this is the more common one to use. So str is Python shortcut for a string. So rather than putting everything together over here, like I did with this, I don't even have to actually, I can return it if I want to use this in another way, which that's fine. I may want to use this in another calculation with another class, but if we just want to return internal information from our class, we override the dunder string method. So if I print an object, guess what I'm going to get? Anybody? Oh,
A string. Or an error.
yeah, I don't know what happened there. I thought I had everything okay. Oh, I probably have something started here I didn't finish. Yeah, it didn't like that. So I put in pass, so it just ignores it. All right. So when you print an object, you get. No, you're not supposed to get a trace back. Oh, I probably have to return some sort of string, don't. Oh, I'm overriding the method. Okay. And if I overwrite it now, then I can't demonstrate why we don't. So what should we do? Comment. There. There is a built-in string method. That means that when you print out the object, it returns a string representation of the object so that you can easily display it. However, by default, it does this. It says, well, the circle calculator object at hexadecimal, that's the memory location. Not particularly useful. But that's what this string method does. Not helpful at all. What we can do is override that. So Python automatically calls __ str. Just like the init method, it's a built-in method. It's called a dunder method because we have double underscores. It's like these guys, this is a dunder method. This is actually a string, but this is a dunder method that returns the name of the starting point of the program. Okay, that may have been more than I wanted to say. So we can in this do anything we want. So I can say, I'm just going to do a string. I'm not printing anything. I can still use F formatting. The area is, and I'll just put in self.area. Oops. Somebody forgot those guys. Self.area. There. So that's the string I'm returning. I can display that string in any type of interface I want. Web, GUI, doesn't matter. But I do have to return it. I can return it directly like that because I'm returning a string. Is this a better representation of the object? Gives us a lot more information, doesn't it? What would we do with a hexadecimal memory address? It's something to know, but that's about it. Every variable, every object, everything has a memory address that when the program says, I need a memory address, the operating system says, oh, here, use this one. And memory is referred to in hexadecimal, which is it's base 16, and it goes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. That brings it up. Oh, A, B, C, D, E, F, G. G is in there. Now we're returning this. What do you suppose we're going to get when we print our object now?
The radius,
The what?
the radius.
Yeah, we're going to return this. And it doesn't matter what kind of program I have here. I would display it how that program I want to display it. So we do this and we'll put in a big radius. There, boy, there's an area. I don't have any commas and it doesn't look beautiful, but you know, I have tested it and it probably works. But how would you test this to make sure that was right? For those of us that don't know math, what do you suppose I do? Find a radius, find a circle calculator on the internet. They're all over the place. And then I confirm that I actually got the formula right. That's what I do. So to recap, we have our ob class, which we call circle calculator. Set means that we're bringing information from the outside world into our object or class, however you want to think about it at this point. Get returns that information to our class. Oh, we didn't demonstrate get, did we? Oh yeah, let's demonstrate get. No, we did. We just didn't print area, did we? So you can do it either way. So we could print f string. This is the area. Oh man. Sometimes that helpful stuff is not helpful. And we do area. Now, is this exactly the same? I mean, other than I didn't say it right. Are we doing in effect the same thing? Yeah. Here we're returning the value, assigning it to variable and printing it. Here, we're not returning the value. We are getting a string representation of it, which is fine. But if we wanted to do further calculations, we have to have this. Then we could do area times something else. We can't do area times something else with a string. So they both have different purposes. We're not going to do that in this program. Just wanted to point it out. Okay, now set puts things in, get gets things out. This is a method that does neither. It just calculates an internal variable, calculates the value of an internal variable. I could return it right here. That'd be fine. But I want to separate things to kind of pound in the single responsibility thing. Don't do multiple things on a line. The other rule of thumb is don't do more than one thing in a method. Don't calculate something and then print it and then do something else. Don't do different things. If it says calculate area, that's it. We could return, which is fine. We're calculating the area and we're returning. So single responsibility. Have any program or class or whatever do one thing and do one thing really well. Because then we build up building blocks that we can assemble over here any way we want. So it is just like getting out Legos. We're making different Legos that we can put together in any way we wish. And then you can end up with something as beautiful as this. Look at that thing of beauty. Oh, I got kind of carried away. Oh, I must have used the title thing from utils. And I did some formatting, put in the column, this, and you can see we're going to have a couple more calculations, but what I've done is the pattern. Oh, it says make a tkinter GUI program. Whoa, that's a little advanced. We're doing GUI this week, but to go from GUI to doing this and importing something and doing it as a class, yeah, it's a challenge. Once in a while, I have somebody that can do it. We are done with that. Unless, let's see.